In this video, I'm going to show you the properties of logarithms. So we have a few of these. The first one we're going to talk about is the product property. So if you have log base b of m times n inside of the log, that's the same as saying log base b of m plus log base b of n. You are just expanding it. So multiplication, if you are multiplying inside of the log, that means that you add. Okay, so a couple of examples. We have log base 2 of 7 plus log base 2 of 4. So we can condense that into log base 2 of 7 times 4, which ends up being log base 2 of 28. Same thing with number 2. We have log base 4 of 2x and log base 4 of 4x squared. So we can condense that to log base 4 of 2x times 4x squared. Well, 2x times 4x squared is going to be 8x to the third. Okay. We can also expand the logarithm using this product property. So if we have log base 7 of 45 and you want to expand that, what two numbers when multiplied will give you 45? So 9 and 5 would work. So we can say log base 7 of 5 plus log base 7 of 9. That's the same thing. Now we have the quotient property. So if we have log base b of m divided by n, that's the same as saying log base b of m minus log base b of n. So division and subtraction go together, and it's always the top minus the bottom. So we can condense these. Number 1, we have log base 3 of 24 minus log base 3 of 8. So that can be condensed to log base 3 of 24 divided by 8. Well, you can simplify that. 24 divided by 8 is 3, so we have log base 3 of 3. Same thing with number 2. We have log base 4 of x to the 9th minus log base 4 of x squared. Condense it into 1. So we have x to the 9th divided by x squared. Again, you can simplify that. X to the 9th divided by x squared is x to the 7th. We can also expand the logarithm. So if we have log, if there's no base, remember it's base 10. So we have log base 10 of m divided by 7. So we can expand this to say log of m minus log of 7. That's your quotient property. Next, we have the power property. So if we have log base b of m to some power n, we can actually kick that power out in front, and we get n times log base b of m. So let's look at some examples. With number 1, we have 5 times log base 4 of 2, so 5 would be the power inside. So we can say log base 4 of 2 to the 5th. Well, 2 to the 5th is 32, so we can say log base 4 of 32. Same thing with number 2, we have 1/3 log of 8. So that 1/3 will go as the power to the 8. So we have log of 8 to the 1/3. Now, if you remember, whenever you have a rational exponent or a fraction as an exponent, that means that you are taking a root. So in this case, this is the cube root of 8. So this really is log, the cube root of 8 is 2. So this is log base 10 of 2. We can also expand, like number 3, we have 3 log base 10 of 4 to the x minus 1. So we can actually kick out this exponent here, and it gets multiplied on the outside. So we have 3 times x minus 1 log of 4. Simplify that just a little bit more. You can distribute that 3, so you get 3x minus 3, and this needs to go in parentheses in front of the log of 4. So that's your power property. Now we can use these properties to condense these logarithms. Remember that they always have to have the same base in order to condense, okay? So like looking at number 1, we have log base 2 of 15 plus log base 2 of 4 minus log base 2 of 6. So if we have that addition there, that means that we are multiplying those two logs. So we have log base 2, and we're going to have a lot inside the parentheses here, but we're going to have 15 times 4. Then if we have that subtraction, that means that we are dividing by the 6. So we can condense this to log base 2 of 15 times 4 divided by 6. Well, 15 times 4 is 60. So we get 60 divided by 6, so we have log base 2 of 10. That is that logarithm condensed. Let's look at number 2. We have 1/3 times log base 5 of 8 plus log base 5 of 27 minus log base 5 of 3. So that 1/3 is actually going to get distributed to each of those logs. So this is really 1/3 log base 5 of 8 plus 1/3 log base 5 of 27. And then we'll just tack on this log base 5 of 3. So you can do this in any order that you want. You could do your power property first, you could do your product property, whichever way you want to do it. So I like taking cube roots of small numbers, so I'm going to do my power property first. So this 1/3 is actually the power of these logs. So I have log base 5 of 8 to the 1/3 plus log base 5 of 27 to the 1/3. Now if it's to the 1/3 power, you're taking a cube root. So the cube root of 8 is 2. So I have log base 5 of 2 plus the cube root of 27 is 3, so I have log base 5 of 3 minus log base 5 of 3. Now you can do your product and quotient properties. So if you are adding right here, you are going to multiply. So we have log base 5 of 2 times 3 minus here means that you are going to divide. So divide by 3. Well, 2 times 3 is 6. 6 divided by 3 is 2. So this condenses into log base 5 of 2. Okay, so now we're going to expand the logarithms. I like expanding more than condensing, so I just think it flows easier. So looking at number 1, we have log base 6 of x times y times z to the 4th. So if we are multiplying inside the logarithm, that means that we are adding all of these variables. So we have log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. The only other thing we have to worry about is this power right here, so we'll kick that out front there. And so this expands to log base 6 of x plus log base 6 of y plus 4 log base 6 of z. Let's look at number 2. We have log base 10 of the square root of 7x to the 3rd. So I can actually rewrite that square root as a rational exponent. So this is 7x to the 3rd all to the 1/2. So that 1/2 can come out front, and we will have log of 7x to the 3rd. So now we need to rip apart that 7 and that x to the 3rd. So since they are multiplied, we are going to add them. So we have log of 7 plus log of x to the 3rd. The only other thing we have to do again is a power property, so we're going to kick that 3 out front. So we have 1/2 log of 7 plus 3 log of x. All right, let's look at number 3. So I have log base 2 of y divided by z to the 5th, all of it squared. So first thing we're going to do is we're going to kick out that 2. So we have 2 log base 2 of y divided by z to the 5th. So since we are dividing, that means that we subtract our logarithm. So this 2, it's going to get multiplied by the expanded logarithm. So even up here, I can put parentheses. So we will have log base 2 of y minus log base 2 of z to the 5th. Now we just need to kick out that power again. So we have 2 log base 2 of y minus 5 log base 2 of z. That's your expanded logarithm. Now this graphic organizer here is a really helpful tool. So in the Google Classroom, I do have filled in notes, so I encourage you to either print this out, copy it down on a piece of paper. This tells you all of the rules and gives you some examples. So it's all the stuff that you need in one place. So please go on the Google Classroom, look at the end of the notes, and try to fill in this graphic organizer.